let's talk about what are the factors that are affecting the synaptic transmission, kind of like the speed. Some factors does increase the synaptic transmission, some do not. Okay, the first factor that is affecting the synaptic transmission is actually the pH of our body fluid itself. Right, alkalosis, which is pH more than 7.45, actually helps to increase synaptic transmission, whereas acidosis, in which the body pH less than 7.35, decrease synaptic transmission. And this has actually as a close relation to the hypocalcemia and hypercalcemia. What does it mean by that? So imagine in our blood we have this plasma protein. Okay, this plasma protein, it is negatively charged, therefore it tend to attract the positively charged ion to bind to it, which includes the calcium and the acid H+. Now this H+ is the one that actually determines the pH. The higher the H+, the lower is the pH. The lower the H+ concentration, the higher is the pH. Now imagine, now let's have a look at the role of the calcium first. Now in the presynaptic bulb, okay, the synaptic end bulb, you have for it to allow the calcium to go in, it first needs to depolarize. Okay, it needs to depolarize, meaning that it will become less negative, and that is when the sodium needs to go in. Now the sodium goes in through the sodium channel, of course, but if we have too much calcium to ionized calcium outside the cell, what happens is that this calcium ion can actually blocks the sodium channel. Therefore, it will stop the sodium from going into the cell. That is why hypercalcemia can reduce synaptic transmission. Similarly, if we have a lot of magnesium outside the cell, this magnesium can also inhibit the sodium channel. That is why hypermagnesemia can reduce synaptic transmission as well. Now, if we have in alkalosis, pH is high, therefore H+ is low. Now what happens is that when this plasma protein, when there is less H+, now this plasma protein is available to bind to more of the calcium. So this calcium will then bind to the plasma protein. Therefore, what is left of the ionized calcium or unbound calcium, it will be lower in concentration. This ionized calcium will be lower because most of the calcium will bind to the plasma protein when there is alkalosis. Therefore, when there is less ionized calcium, this is also similar to hypocalcemia. So hypocalcemia, it can increase the synaptic transmission. Same way. Why? Because it won't block the sodium channel in the presynaptic neuron. Now, we talk about this now. Hypoxia and hypoglycemia will decrease synaptic transmission. So if you think about it, we need a lot of ATP in the presynaptic neuron because it needs to resynthesize or synthesize the neurotransmitter, release this neurotransmitter, and all of this require ATP, and this ATP can only be formed when there is enough oxygen and enough glucose. Now the third condition that may affect synaptic transmission is drugs. So stimulants, okay, we call this stimulants. For example, caffeine, theophylline, theobromine. So caffeine is of course found in coffee. The theobromine is found in the tea. Okay, they can actually increase synaptic transmission. Whereas the CNS depressor drug, for example, anesthetic, analgesic, and hypnotics, actually reduce synaptic transmission. So if you think about it, when you are under the general anesthesia or local anesthesia, you will have reduced sensation, or you can just go unconscious because the synapse transmission is stopped. Similarly, if you are taking analgesia, which is painkillers, you have less sensation or reduced sensation of the pain. And hypnotic is when drugs that makes you feel sleepy. Of course, your synaptic transmission is also reduced. Number 4 is toxin or diseases. Okay, there are 2 toxins that I want you to remember today. The first one is the Clostridium tetani toxin, which can cause the disease called tetanus. This toxin, it acts by inhibiting GABA release. If you remember what is GABA, it is an inhibitory neurotransmitter. Therefore, when there is less GABA, there will be increase in synaptic transmission. Because if you remember, we talk about the pre-synaptic and post-synaptic inhibition, right? Okay. So what happens is that when there's increased synaptic transmission, you can see that in those with tetanus, it will present with spasm. So it can present with spasm because it can cause increased synaptic transmission, which eventually can increase the neuromuscular transmission as well, causing the muscles to contract non-stop or continuously, leading to tetanus and spasm. On the other hand, botulism toxin can actually decrease synaptic transmission because instead of inhibiting GABA, it inhibits the acetylcholine release. And acetylcholine, as mentioned to you, it is mostly excitatory. So in botulinum toxin, you can see that there will be reduced synaptic transmission, and if we look at the effect on the muscle will kind of be relaxed, okay, or we call that as flaccid in a generalized Botox toxicity, or in a systemic Botox toxicity, we call that the patient can appear as flaccid rather than spasm. Another factor that can affect the synaptic transmission is actually the activities that are occurring at the presynaptic neuron, which can actually produce this phenomenon known as the synaptic plasticity. So imagine if you're training yourself to do something repetitively. So in the end, what will happen is that you become good at doing it, similar to our synapse. If there is repeated stimulation, okay, what will happen is that the response of the synapse can be augmented or facilitated greater than expected. Why? It's because with every neurotransmitter release, there is increase in calcium accumulation in the presynaptic terminal. In the long term, what happens is that there can be an increase in the postsynaptic receptor sensitivity as well. Why? It's because with each of the simulation, there can be an increased neurotransmitter release from the presynaptic terminus, and this is what we call as the long-term potentiation. However, not all of this occur in all cells. Okay, in some cells, if you have too much repetitive stimulation, it can lead to this synaptic fatigue, in which rather than augmented response, this response can be smaller, and this is mainly due to the depleted neurotransmitter in the presynaptic neuron. Now, if we think about this facilitation, okay, and the long-term potentiation, and that is when reading, memorizing the Quran, the Surah, repetitive exercise or drilling exercise can actually helps to create more memory, that can actually helps to strengthen your memory. It's because you are training your your synapse to quickly send down the information, so that in the end, the synaptic transmission is becoming faster, and it produce a greater than expected response as well.